Kia ora. We're just going to finish off page 38. So, we finished here, so let's get to E. Write down the standard deviation and variance for this distribution. So, our lambda value was 0.6. There were 0.6 cyclones on average per year. So to work out this, which is standard deviation, sigma, or sigma squared, which is variance, I might write that down here. Stand dev and var. Alright, to work these out, you can actually just go to your formula sheet. So in the formula sheet that you will be given during the exam, it says here that the mean is lambda and the standard deviation is the square root of lambda. So with that information, so we know that this is going to be square root of 0.6. So let's get our calculator and we'll just go here and we'll go shift square root and 0.6. So that there is going to be 0.7746. Now, sigma squared, pretty much if you square something in maths, it's just square is the opposite of square root. So if we were to square this, it just takes us back to 0.6. So that means the variance is 0.6. And by definition, lambda is both the mean and the variance. So you can just write lambda there. So yeah, anytime you're trying to work out what the variance is, it just is what lambda is. Okay, on average, how many cyclones would you expect to strike the island in a 10-year period? Now, notice that they changed here. So the thing about Poisson is proportional. So if you increase the rate at which you're looking at it, it increases proportionally. So we were looking at 1 year, and if 1 year gets us 0.6 cyclones, we can then just amp that up proportionally. So 10 years is going to take us to 10 times 0.6, which is 6 cyclones. That's just how Poisson works. It's a proportional distribution. So on average, how many cyclones would you expect to strike the island in a 10-year period? 6 cyclones. So, I mean, I could show a calculation. I could go 0.6 times 10 equals 6. Okay, what is the theoretical probability that 5 cyclones strike the island in a 10-year period? So we're going to use that same proportional rule. So lambda is going to be 6 now, and we're just looking at what x is 5. So p x equals 5, the point. So we can now go into distributions under stat, and then we go f5, f1, f6, across to Poisson, and we're just looking at a point here, and our new lambda is 6, and we're looking at probability that x equals 5. So that probability comes out at 0.1606. Okay, now this here is moving on to a merit style thing, and I've got a way to do these. So let's just write down 4 reasons why you think that the Poisson distribution is appropriate for this situation. Explain your reasons. So what I remember for this, my mnemonic is Poisson. Right? So I'm going to show you what I do. So I go, P means it's proportional, O means it occurs randomly, I means that they are independent events, are independent from each other, and then the last 3 I say simultaneous, occurs never. So I normally write it like this: simultaneous, occurs never. So I just write this mnemonic right at the start of the exam, and P is proportional, whoopsies, it occurs randomly. This is like the basis of the distribution, and independent. Obviously it's a discrete distribution as well, so that's another thing that you can use. Okay, so what we do is we're just going to find 4 reasons. So can you have 2 cyclones at once, or would they join together? I'm just going to write that. So simultaneous occurs never. You can't have I don't even know if this is true. I don't know enough about cyclones. Simultaneous cyclones on the same island. It's on an island, eh? On the same island at once. So yeah, I don't even know if that's true. It's probably not even true. I'm imagining that cyclones sort of like join forces. Okay. Occurs randomly, so yeah, that's pretty good. I mean, we've used this idea of them being proportional. Discrete, because it's a discrete distribution, the amount of cyclones is discrete. So that means we can't, if it's a discrete number, it means we can't use triangular, rectangular, or normal, which are continuous distributions. What's the third reason we're going to go for today? Yeah, I'm just going to go cyclones occur randomly. Are they independent? One cyclone occurring is independent of the other. When you're doing these, what you've written over here, these are the buzzwords. These are the words you're trying to use, right? And don't be afraid to like end up writing, you're pretty much just putting it in context and using these words. So don't worry about just using the word discrete and simultaneous and this occurring randomly and independence. Do not be afraid of doing that. Let me think off the top of my head why else it might be Poisson. Actually, let's just look at the answers. You can stop the video now if you're going to look at your own answer book. What are we on page 38? I am interested in what they say. So they say cyclones are discrete events. Yes. Cyclones are relatively rare events. Nice. Cyclones occur randomly and unpredictably. Cyclones occur. Boom. I think we literally had all of them. How is it that they relatively... Oh, I didn't say a rare event. Occurs randomly. I didn't do that. Occur randomly? Did they do random and rare as separate? Rare events and random. Oh, maybe I should make randomly / rare. Rarely. Maybe worth adding into that. But yeah, that gets you a merit mark most of the time. And if you get an M5, you've pretty much already passed the exam. Sweet.